Hi once again, senior high students. In this video, we'll still talk about uniformly accelerated motion, but since we're in the third video, our learning target would be I can arrive at the appropriate working equation given a problem on UAM. So we already know how to apply the right sign conventions. We already know how to apply given variables. So our goal now is to choose what equation would work for a given UAM problem. Now to start, I'd like you to recall that we have four basic kinematic equations in UAM. This is for horizontal motion or motion along the x-axis, okay? So there are four equations and the question would be, which exact equation do we use if this is the physics problem, okay? So before we start trying to figure out what equation would work, the first steps requires that we identify what are the given variables, okay? So before you try to identify the equation, make sure to prepare this. You list down the given variables, the variables whose values are known in the problem, okay? And then the required to find, I'd like to call that RTF for short. When we say required to find, that's the variable or variables that we are required to solve for. Let's say, for example, solve for the final velocity of the car or what is the acceleration of the car. So that's the required to find. It's what you are tasked to solve for. Okay. Lastly, we have the missing variable that we call, okay? When you say missing variable, that's the variable which is neither given nor required to find. So meaning to say, we don't know the value of the missing variable, that's why it's called missing variable, and yet it's also not the required to find. We're not being asked to solve for it. Or in other terms, the missing variable is the variable that is not mentioned in the problem at all, okay? Now let's have an example, okay? So we have four equations, as you can still remember. So when do we exactly use each one of them, okay? I'd like to emphasize something about the missing variable because you might be thinking, Miss Leia, if the missing variable is not mentioned at all in the problem, why is it important that we identify what the missing variable is, okay? It's simple. The missing variable makes you decide what equation to use. Because the thing is this, whatever is the missing variable in a given physics problem, you have to pick the equation that does not contain that missing variable. I'll repeat it. Whatever is the missing variable in a given physics problem on UAM, you have to pick the equation that does not contain the missing variable. For example, okay, look at equation 1. Final velocity equals initial velocity plus acceleration times time. When do we use it? We will use it if the missing variable in the problem is displacement, okay? So once again, whatever is the missing variable, you have to pick the equation that does not contain that missing variable, okay? So if you have a problem, if you have a physics problem, the missing variable is displacement, we pick equation 1 because it does not contain displacement. If it doesn't make sense, it's this simple, okay? If displacement is the missing variable in a problem, it means that we don't know the value of displacement. And we don't want displacement to appear in our equation because we have nothing to plug in for that in such case, right? So that's how it makes sense. Going forward, for equation 2, you will use this equation if acceleration is the missing variable, okay? Why again? So the way we choose is whatever is the missing variable, you have to pick an equation that does not contain that missing variable. And if you look at this equation, you don't see acceleration there. So that is the right equation to pick if the missing variable in your problem is acceleration. So once again, I'll repeat why it's logical, simply because if the missing variable in the problem is acceleration, it means that we don't know the value of acceleration. And we're not solving for it either. So if you pick this equation, you don't have a problem. You're not gonna say, oh, I have nothing to plug in, I don't know the value of this. No, right? Because again, you're picking an equation that does not contain the missing variable. It's that simple. Going forward, okay. When do we use equation 3? I'd like you to try it. So I'd like you to pause the video at this point and try thinking, when do I use equation 3? What is the missing variable for you to use equation 3? Okay, the correct answer is final velocity. If final velocity is the missing variable in a given problem, you will use this equation because it does not contain final velocity. Ganun lang, it's as simple as that, okay? So, next question. When do we use equation 4? Okay. When do we use it? Okay. It's simply going to be used if the missing variable is, of course, time. Why? Okay, you're gonna use equation 4 if the missing variable is time, simply because you don't see time in the equation. And you will be sure you have something to plug in for all of these variables. Or if it's not something to plug in, that variable would be the RTF, or the required to find. That's how it works. Going forward, okay, we have initially worked on this problem before, but in this particular part, I'd like us to work on the task of identifying the right equation, because previously, if you still remember, we already know what the variables are, okay? It's the same problem in video 2, and we already identified that initial velocity is 0 meter per second, displacement is 100 meters, and acceleration is 2 meters per second squared, okay? So the question that I left you at that point was, what about final velocity and time? What are they if they are not a given? Okay, so let's continue with the question. Because if you remember, the variables in the problem, these 5 VV dot, those 5 variables in kinematics, okay, they're either the given, if not that, RTF, or required to find. If not the RTF, then it's the missing variable. Okay, now let's see. We know that the given variables are these 3, right? Because we know their values, okay? What about the RTF? What's the RTF in this problem? It's simple. Look at the question. How much time did it take for the cyclist to cover the said distance, okay? How much time, which means to say that time would be the RTF, okay? Why? RTF is the required to find. It's the variable we are solving for. Therefore, time is the required to find in this physics problem. Miss, so what's final velocity then? Obviously, final velocity is the missing variable. Why? Because final velocity is not given, we don't know its value, but it's not the required to find either. So final velocity would be the missing variable. And once again, whatever is the missing variable in the problem, you have to pick the equation that does not contain the missing variable, okay? So for you to be able to solve this problem, let's look back at the choices that we have, okay? So what's the missing variable again? Final velocity. Therefore, we're going to pick the equation that does not contain final velocity, and it's this one, okay? Therefore, for this particular problem, since the final velocity is the missing variable, we're using the equation that does not contain the missing variable, and that's v sub I times time plus AT squared divided by 2. And that's our working equation for us to finally solve for this problem.